Hello, everyone. My name is Konstantinos Kopsinis, but you can also call me Konstantin or Kostas. Welcome to CS165 project, and this is a section on Docker. Now, the reason we are doing this is because, as you already know, you need to test your local code inside the Docker container so that you make sure that it will actually work when you submit it on our server, on our testing server. And by all means, this is not going to be a very detailed walkthrough of Docker. I'm not an expert either, but I'm definitely going to give you all the tools that you need in order to be able to navigate through the starter code that we've already given you, and so that you can actually know what it does, and so that you can actually do your own customizations. And this will be very helpful, especially by at the end of the project when you will need to do an experimental analysis, in which phase of the project you will definitely need to create your own makefile targets and customized Docker commands. Um, Section's main goal will be to guide you through and walk you through the instructions that we have attached in the starter code. There is uh, a Docker quickstart.txt file, and there is the make file. So we're going to explain to you what all these things do, so that you do not use these make file targets as magic commands, magic Docker commands that you do not actually know what they are doing. And I'm also going to explain to you in a way that you can actually create your own targets and actually understand what is happening. Now, if you are too familiar with Docker, maybe this is not the right section for you, but I do encourage you to skip the initial part of the lecture and go to the end of the presentation, because I'm definitely going to share you some extra code that you can definitely attach to your makefile and make your life much easier with this project. So let me share my screen. And okay, so here's my screen. This is essentially um, this is my cloned repository. Let me actually delete this because you're not uh, gonna see that in the started code. So yeah, so you can imagine that like I'm just starting. I've cloned my project. I have my own repository, and what I want to do first is to explain what this docker quickstart.txt file says. I'm not going to be very detailed because you can also read it in, yourselves. But essentially, what it says is that you need to install a Docker desktop, and I have. So um, if I start here, you can see that. And it's important that you actually start it in the background. So now, even though you didn't see anything, if I go to my upper my upper toolbar, which is actually in my other screen, so you cannot see that, there's like a new tab on about Docker, um, on which I can also click and press and clicking to on go to the dashboard. um, it actually starts the dashboard as well if we really want to have an interactive interface with Docker. Let's leave it aside for now. Um, yeah, and okay, so we have Docker desktop, and now our Docker commands are actually gonna work, because if you don't start I don't think that uh, you're going to have responses to that. Okay, and now the next that you're gonna need to do is run this command inside the project's root path. So I'm not gonna do this again, but essentially what this is going to do is create a Docker image, um, which is going to be a container containing all these different tools that you will need for the development of your project. And a very quick side note, you also have Valgrind installed, so you do not have to do this manually again. There's also Tmux and Python and all the important stuff, GCC compiler, Vim. Yeah, so you have everything that you need inside your Docker image. And in order for you to make sure that this actually worked, you can actually type Docker image list and check that your image is created. And mine is there. It's been there since I started this project almost 1 year ago, and it's still working. So it's only a one-time process, and you shouldn't need to repeat it in the future, as it explains here. Okay, now the next thing that I'm going to do is actually run a makefile target, and I'm going to run the run target here. So I'm going to type make run and see what happens. Okay, it compiled, it ran 2 tests, and it stopped. Okay, what did just happen? So the first command that we initiated was essentially a Docker container run command. And the important part of this is that it actually binds our folders in our repository to the folders inside the container. So the Docker container actually has a different file system. The root of it is CS165. We've declared this. Um, Let me see. Yeah. So the working directory is CS165. So in the Docker file, we already said that the root is going to be CS165. So what I'm actually doing here is that I am binding the SRC file in my a repository with an equivalent SRC folder inside CS165 in the Docker container. And the same thing I'm going to do with project tests, infra scripts, generated data, and student outputs. What this also does is that it enables you to read these, whatever is included in these folders, but you can also edit it, and the changes are going to be transferred to your local file system. So even if you are inside the Docker container in an interactive mode and you edit these files, the changes are going to apply to the original files out of the container. So this is like an important thing. The other argument that we are passing here is -d, which means detach, and that's why we didn't actually get inside the container. We didn't have an interactive terminal here because it detached as soon as it was created. The --rm means remove after completion. So whenever there are two different modes. One is a stopped mode, and the other is like the deleted. So you can stop a container but not remove it, not delete it. So this --rm actually removes it after stopping. And the -d and -i, let me see my notes. Okay, so -i means keep in open, and the -d means allocate a terminal. So these two together mean an interactive shell inside container. Well, we didn't got inside the shell because we also detached, but yeah. So, and then CS165 is the name of the image that we are using, and we also include bash here. Yeah. Now, and then what else did we do? We executed this container, and so inside the container we did Docker. So this is like this is Docker essentially. We did Docker exec, and then so the Docker container ID is the unique identifier of the running container. So what we already did here is that when we run Docker container run, this actually returns the Docker container ID. So we made sure to actually store this ID inside this variable so that we can actually reuse it here and explain to the terminal and give these instructions of running this executable file, this script, inside that particular container. And what did we run? We ran bash, and this is like the script. And this is just a very simple test script that um, we have there for you in order to make sure that everything works fine. After that, you can go inside the infrascripts and actually read it here, right? Remember, the path that we are giving here is not a path that can apply to your file system of your computer because this is going to run inside the container. So this is the path to the test.sh script when you're actually inside the container. We're going to come back to that many times in the next couple of minutes. Yeah, so the test actually started, the server did test one, test two, and shut down, and I'm not going to explain more on that. Yeah, okay, so you cannot do much with this target because it is what it is. It starts, it stops. It's not very editable. So, and uh, yeah, so now I'm going to actually explain the start container target. And this one here actually demands that we pass a test dir and an output dir as arguments. Now, you can also hard code these paths here, and it should definitely work, like base dir slash your test dir and your output dir. But for now, I'm not going to make any changes on that, and I'm just going to reuse this. Okay, so what I'm going to type is make start container, and then I need, let me find my path here. I have my, um, yeah, here are my notes. Okay, so, okay, I'm going to reuse actually the folders that we already have here. So, um, make start container. Okay, so my output dir directory is going to be the student outputs here, and then my test dir is going to be the generated data. Again, you can pass this as arguments of your start container command target, but you can also hard code that here. So let's see what this does. Okay, it worked. So what did just happen? Um, Essentially, the first part here is the same that we already explained. We make sure that we bind our local directories to the directories inside the Docker container. But now what actually happened is that our Docker container ID got saved inside this file. So now we have this file created here, the status.currentContainerID file. And this is useful because we don't actually need to remember or write down anywhere else the Docker container ID. We have it here. And what this actually is going to help us do is being able to reference this Docker container again in the future. Now, once we've started this container, we can actually type Docker container list and make sure that we actually created it. Yeah. So here's the container. It has an ID. It's a shortened version of the full one. It also has a name, inspiring Germain. Okay, so we have this container up and running. What else can we do with that? What if we run this command again? Uh, then what is actually going to happen is that now I can actually go back Docker container. list, and I have two more containers. So be careful, because if you run this too many times, and you will end up with too many containers to handle. And it's fine, you can actually go back and delete them. Now, what you really need to pay attention to is that only the latest ID is going to be stored inside your container ID file. So if you check this here, this is the ID of the latest container, which is the one up here. Okay, so let's start removing them. There are a couple of ways to do so. So um, we can do docker stop, and then we can use the container ID here. It can either be the shortened version or even like the full version here. And if you can see here, now it stopped, right? And I can do the same thing, docker stop, with the name. So I can actually use the name here. And then again, docker container list, and I only have one container. Now, are these completely gone? Not exactly, because if I actually do docker container list dash a, yeah, so actually they got removed, but the reason they got removed was because when I actually started it here, I had this dash dash rm. Now, if I didn't have that, so let me actually remove it. And I actually now do start container. Okay, docker container list again. And now I may docker stop objective nash. Okay, now actually I mean, if I do docker container list, it's just that. If I do docker container list dash a, you can actually see that you have still this container, which is up, but you also have this container, which is exited. So it stopped, but wasn't removed. And you can definitely go back and, make it up again. And I'm also going to share you what happens in Docker Desktop. So let me find it. Where is Docker Desktop? If you open the dashboard of Docker Desktop, you can actually see that one container here is running, and the one here is stopped. So yeah, just pay attention to that stuff. You may like forget to use the dash dash rm or whatever, and then you go back to your dashboard and you actually realize you have a like a whole list of stopped containers. So yeah, you shouldn't have too many. Just one, I guess, is fine. And yeah, just make sure to have its ID here, or maybe do Docker container list so that you actually know which one you are referring to. Another command that you can actually use is docker container kill, docker container kill. And I mean, let's do what will happen if I do it here. Yeah, so docker container kill is still about running containers. So that's why it didn't work. Docker container kill, and then maybe I do inspiring Germain. And then I do Docker. Yeah, so Docker container kill also removed. No, I think it was removed because we had like this argument here. Yeah. But yeah, you got the point. Now, if you don't know which one to remove and you don't want to do Docker container list all the time, then you have this very convenient target for you. So let me actually go back, and you can also delete from here, from the interactive app. And okay, so let's go back. We can actually start the container here. And now again, we have this ID here. So if I just run make stop container, oh, and actually let me show you, yeah, it's here. Yeah, so make stop container. Yeah, so this is going to do what? It is going to read the contents of the container ID file. It's going to store it here in this variable, and then it's going to stop the container and also remove um, the file here. So everything is clean and back to normal. Okay, so we did all this stuff, but we didn't actually manage to get interactively inside the container and actually do stuff inside it. So I'm going to go back and start a new one here. Okay, I have the make start container uh, command. Now I have the container again here, and then I'm going to do it like the hard way. So Docker container list. So I have this container here, this awesome diffie, yeah. And I'm going to run docker exec dash it, so it's interactive. Um, awesome diffie bash. Okay, okay. So now we just got inside the container. So this is our new root, and we have this CS165 root directory. And pwd, yeah, I'm there, right? If I do ls, then I can see all the directories that that I made sure to bind inside the Docker container. Now, why this is important? This is important because you may need to go and manually run the data generation script, okay? And this is important because especially if you want to run stuff outside of your container, you will really need to make sure to fix the paths. And what do I mean by that? Uh, so the generated data folder, as you have already seen, actually generated two CSV files with some random data. And then you have a set of SQL queries that you will need to pass in order for the in order to pass milestone one, right? Okay, so here's like a very quick um, uh, note on the load query. So the load query here has the path of the CSV, right? So this path is only going to work only if you do this testing inside the Docker container, because it really needs to be the path of the container. So if you're actually going to test your queries locally, you will definitely need to go back and either change this manually or rerun the data generation script. Uh, and I think it is, um, um, yeah, the data generation script, it is the one in infra scripts, I think is, no, it's project tests. Yes, you go to project tests and gen all for staff use.sh. And so this was also called during the make run target, because this test.sh script is also calling the generation all for staff use. But you can also go back here and actually mess up with the arguments in order to generate your data based on what you want. So um, make sure to pass the right arguments about the output test directory, the Docker test directory, and you can also manage all other stuff like the table size. That's why the size here is 10,000. If I go to the generated and .csv, this should be no, this is not even 10,000, because when it's called, it passes some other argument. But yeah, do feel free to play around with this data generation script. It's going to be very useful to you. So let's try to run this, but inside the container, okay? So in order for this to work, I'll need to do cd cs165. Well, I'm already there. Project tests data generation scripts, and then I'm going to run gen all for staff use.sh. Yeah, so this worked again. We're here. And yeah, now I can actually, let's say, exit. Now, Docker container list. Yeah, our container is still there and running. And now I'll try to run a milestone, okay? So in order to do this, I'm going to go back to the make file. Yeah, so this is the target. So I'm going to type make run mile ID equals 1 and server weight equals 2. Okay. And this is like now it's actually testing milestone 1, and obviously I'm failing. I have no idea why I passed number 4. Uh, Now, the reason I showed you to go and generate your data on your own is that if I revert back to the make run script, and then I go the run mile script. Well, never mind. Sometimes the run mile doesn't work, and this is because you didn't actually create your data on your own, or maybe you forgot to run the make run target. So just make sure that you actually have the generated data here. And one way to do this is by doing this interactively inside the Docker container. Okay, maybe I've said too much, but now I'm actually going to run a couple of more targets so that I can actually give you some ideas of what else you can do. Okay, so let's say that we are here and we want to make our own targets. And the first one I'm gonna want to create is an interactive one, and that's how what I choose to call. And let me paste my notes here. Okay, so what did I just do? We've already have a container up and running, right? So we definitely don't want to uh, read to do Docker container list and then see the name, and like it's just too tedious to do all the time. So this is just a very nice target that we can actually use so that we actually manage to like if I just do now make interactive. Um, Missing separator. Um, in see. Oh, okay. So I did the copy paste and like it didn't understand the tab. So I think now, yeah. So essentially we took the shortcut and we read the contents of the uh, container ID, and then we did the execute. So we actually managed to get inside the container. So this is again, I guess, like the one that you're gonna need the most. Okay, so let me show you another thing now. I exit the container and I'm going to use another target that we can run here. Um, so let's say make edit. So again, this started a new container, okay? Um, it did these bindings here, and we could also use IT here and dash dash rm if we really want it to be precise so that it actually gets removed by the end. And now this is obviously not the best thing to do. I mean, the good thing here is that I actually hard coded the paths that I want to do compared to the start container. But I didn't actually included the echo thing here. So uh, when I just exit here, I will have a lot of containers dangling. So maybe this is not the best thing. I'm just messing around and show you like things that you can do. Container list, at list A, and you have, yeah, some extra stuff here. And the other thing that I wanted to show you is, yeah, so let's say that you actually want to run a script, and then we can actually take this here, because like this milestone actually runs a script, right? So you can come here and we can call it run any script. And just use this here to run your script.sh. So this is for the containers that are already running in the background, and you just want to run a script inside the container. So this actually makes sure to connect to the particular container and run the script and then exit. Let's conclude. We don't need to do this again. There are all sorts of ways to uh, manage your Docker scripts, and make sure that you pay attention to which containers are up and which are not. For example, here, again, I've done something wrong, and because I wasn't paying that much attention to what I was doing, I was just showing around. And um, the most important thing is to know when something runs inside the container and when it doesn't, because this changes the file paths, okay? And this is important because at first you should definitely try to make everything work locally outside of Docker. And then once everything is fine, then you actually go inside Docker and move on with your testings. Okay, so that was it for today. I'm sorry if I actually talked too much and took too much time to show like some basic stuff. But thanks for sticking around, and see you in lab.